Driverless Cars, a Proposed Solution by Josh Schwartz. Just to give a brief description, two of the biggest issues facing driverless cars are mapping and sensor technology. Currently, a manually driven car with a 360-degree view camera must drive through an area to provide a 3D map of that area. However, sending a mapping vehicle through an area only provides a one-time map. And as we know, the roadways are an ever-changing environment. In regards to sensor technology, currently, driverless vehicles rely on sensors to detect obstacles in their path. Unfortunately, most current sensor technology is easily fooled by bad weather. My proposed solution is to utilize current camera mapping technology combined with mobile network technology. Equipped with 360-degree view mapping cameras, which would constantly produce a real-time 3D map of the surrounding area, all driverless vehicles in a large area would generate real-time 3D maps. And using mobile network technology would connect with the other driverless vehicles within the same large area, sharing their information all the time and creating a real-time 3D map of the entire region. Not only would this give driverless cars a real-time and reliable view of their surroundings, it would also reduce the need for sensors since the vehicle would see any possible obstacles in its path and also any future obstacles that could cross its path, as other vehicles in the area would be relaying this information. Now to go a little more in depth with the problem description. As I mentioned before, one of the biggest problems facing driverless cars is mapping. According to an article in Vox.com entitled 5 Big Things Still Standing Between Us and a Glorious Self-Driving Car Future, and I quote, Google's self-driving cars work by relying on a combination of detailed pre-made maps as well as sensors that see obstacles on the road in real time. Both systems are crucial and they work in tandem. Before Google can test a self-driving car in any new city or town, its employees first manually drive the vehicles all over the streets and build a rich, detailed 3D map of the area using the rotating LiDAR camera on the car's roof. The camera sends out laser pulses to gauge its surroundings, and the people on Google's mapping team then pore over the data to categorize different features such as intersections, driveways, or fire hydrants. The car uses the map as a reference and then deploys its sensors to look out for other vehicles, pedestrians, as well as any new objects that weren't on the map, such as unexpected signs or construction. Relying on this mapping system will pose some major challenges. Right now, Google has only built detailed 3D maps for a relatively limited number of test areas. For self-driving cars to go mainstream, Google would have to build and maintain detailed maps all over the country, across 4 million miles of public roads, and update them constantly. As mentioned before, sensor technology is the second major issue facing self-driving cars. According to an article in 9clouds.com entitled What are the Biggest Driverless Car Problems, and I quote, Right now, most driverless cars are stumped by harsh weather. Heavy rainfall interferes with sensors, and snow on the ground makes it hard for vehicles to read lines in the road. All the little mistakes that Google Maps or Siri make will need to be taken care of too. Chief among driverless car problems is ensuring the vehicles are not easily fooled. These articles reinforce that two of the major problems facing driverless cars are the current mapping technology and the current sensor technology. My proposed solution focuses mostly on these two main issues, but also addresses the issue of ethical decisions that the driverless vehicles currently must make. Also from the 9clouds.com article, What are the Biggest Driverless Car Problems? Quote, What if scenarios have already been programmed by the people who sent the vehicle forth? And that will have to include programming for some heinous dilemmas. For example, if a couple of kids ran out in front of your vehicle, you may have to choose between swerving at risk of your safety or staying on the path at the risk of theirs. My proposed solution would hopefully remove the need for these so-called what-if scenarios. Next, I want to talk about the existing technology. The story of the current driverless vehicle technology isn't all doom and gloom. There are several bright spots, including the current driverless semi-truck technology, which was recently highlighted on 60 Minutes segment, Will Driverless Trucks Soon Share Our Roads? Driverless trucks are already being tested on public roadways and are expected to be tested without a human on board by 2021. According to an article on CBSNews.com entitled Driverless Trucks Being Tested Right Now on Public Roads, and I quote, Chuck Price, Chief Product Officer at Too Simple, an autonomous trucking firm, sensor cameras and radar devices affixed to the rig feed data to an artificial intelligence-driven supercomputer that controls the truck. Prince says his product is superior to others, can see further than any other autonomous system in the world, can see forward over a half mile in the day, in the night, and in the rain. Top auto manufacturers are also working on the driverless car issue, including Ford, GM, Tesla, Honda, Toyota, BMW, VW, and Volvo. With top auto manufacturers working on the driverless car problem, there are several benefits driving the technology. According to an article in MIT Technology Review entitled Self-Driving Cars Take the Wheel, one of these benefits is real-time route optimization. And I quote, real-time route optimization, autonomous vehicles connect with other vehicles and the traffic management infrastructure to incorporate real-time information on road conditions and traffic level into route selection. Dubai is also stepping up to the driverless vehicle challenge. Recently, a fully electric Jaguar I-Pace that is said to be level 4 autonomous, meaning the driver may be distracted and doing other things while the car remains in control, but the driver may also regain control at any time. It was tested there. According to an article in the national news entitled First Driverless Car Hits the Streets of Dubai, quote, the prototype Jaguar I-Pace was modified specifically for the exhibition to show how far technology has developed. The car is equipped with radar cameras on the front and back, another camera for traffic light recognition, and a roof-mounted GPS receiver. These are just a few examples of the breakthroughs happening within driverless vehicle technology. These articles show that progress is being made towards the goals of autonomy and that we are closer than ever to having driverless cars break into the mainstream. On their own, all of these technologies are impressive, but perhaps combined, these systems could become one working system that would help solve the problem. My proposal. My proposal is using existing technology to help solve several of the real-world problems facing driverless vehicles. A single vehicle would be equipped with an artificial intelligence-driven supercomputer similar to what is equipped on driverless trucks, along with 360-degree view, radar, LiDAR cameras like those equipped on the current crop of driverless semi-trucks and Google mapping cars discussed earlier. With this system equipped, each individual driverless car would be able to generate its own real-time 3D map of the area. This map will be automatically updated each time the vehicle drives through the area. Utilization of this camera system in this way would eliminate the need for manually generated maps. And the maps would also be a current view of the area on that day rather than being an outdated map of the area which driverless vehicles currently rely on. Each vehicle would also be equipped with advanced sensor technology similar to that found on driverless trucks. Using this system of sensors would better equip the driverless car to handle poor weather, which is also a problem that has plagued previous versions of driverless vehicles. Using a combination of both the described camera system as well as the described sensor system, each individual driverless vehicle will be able to operate self-contained. While each vehicle can operate on its own using these systems, the plan really comes into its own when the systems are applied to a wide scope of vehicles. Imagine a downtown city center where all the vehicles on the road are equipped with my proposed camera/sensor technology. Each vehicle would be generating its own real-time 3D map of the area By adding in a mobile network system to each vehicle, the cars would be able to communicate with each other and share data. This includes maps as well as any hazards in the roadways. With all driverless vehicles in the area being able to communicate and share data in this way, the vehicles can not only generate their own real-time 3D maps, but can also add in information gained by other vehicles in the area to make a highly detailed map that would include any hazards that may be in the area. Using my proposed system would reduce the need for sensors placed on driverless vehicles to detect hazards or obstacles in the area. Other vehicles in the area would already have assessed the situation and sent the required information to all other vehicles in that area. Vehicles in the area would effectively know exactly what is coming up because they've already received the information from other vehicles in the area. Let's take a scenario that is often thrown around. What if a group of children run into the road in front of your car? Currently, a driverless vehicle would have to rely on its sensors to detect the children and respond in an instant. This is where ethical decision-making comes into play. The vehicle may decide to risk its passenger's life to avoid hitting the children, which is not an ideal compromise. With my system, the driverless vehicle would already be aware of the children approaching the road, because that information would have been sent from another vehicle in the area. This gives the car approaching the children much more time to decide how to deal with the situation. This would hopefully reduce the need for ethical decision-making, as the vehicle would no longer have to make an instantaneous decision and rather have plenty of time to work out the problem in a safe way for all parties. My proposed system uses technology that already exists, from the artificial intelligence-driven onboard supercomputer currently being used on driverless trucks, the camera technology fitted to driverless trucks and Google mapping cars, the sensor technology also fitted to the current driverless trucks, and mobile technology. It combines them all in a unique way to solve several of the major issues facing driverless vehicles. Security. Security is definitely going to be a major concern. Keeping my proposed system safe from external threats is paramount in keeping vehicles, people, and roadways safe. The automotive cybersecurity market is already in the public eye in a big way. According to an article posted on marketsandmarkets.com entitled Automotive Cybersecurity Market Worth $4.0 billion by 2025, and I quote, "The automotive cybersecurity market is projected to grow from $1.9 billion in 2020 to $4 billion by 2025. Increased use of electronics per vehicle and a growing number of connected cars and reinforcement of mandates by regulatory bodies for vehicle data protection are key factors that will drive the market for the automotive cybersecurity system." Maintenance will also be an issue. Maintenance in the era of driverless vehicles may be a much simpler process, though. Rather than driving to a repair shop and either dropping off our cars or waiting at the shop for the repairs to be finished, driverless vehicles powered by artificial intelligence would likely be able to self-diagnose and even make appointments and drive themselves to repair shops, leaving us freed up to do other things. However, maintenance in the era of driverless vehicles would also be much more costly. According to an article in innovationnetwork.org entitled How Will Car Maintenance Evolve in the Autonomous Vehicle Era, quote, "There is an abundance of equipment involved in building and operating autonomous vehicles, which will also require upkeep. Waymo, the Google self-driving car, features radar that enables cruise control, ultrasound used for assisted parking, cameras for lane keeping and backup assistance, GPS systems to determine a car's position, and sensors that help with navigation when satellite signals are blocked. And then there's Waymo's light detection and ranging, or LiDAR technology, which gives the driver a 360-degree view. The sensors and chips for this car are outrageously expensive, and repairs will cost you." Tesla, another contender in the race to create fully self-driving cars, is considering bundling the cost of maintenance and insurance with its automotive sales, so you won't necessarily feel it up front and you won't have to suddenly come up with the cash at the time maintenance is required. To sum up and conclude the presentation, my goal for this project was to propose a system using existing technology to help solve two major problems that are facing the future of driverless vehicles, which are mapping and sensor technology. Currently, to map an area Companies like Google must send a manually driven mapping vehicle through an area to generate a map. These generated maps are one-time only and must be constantly updated. Also, the sensor technology that is widely used in driverless vehicles is flawed and easily fooled by weather conditions such as rain or snow. My proposed system will have each driverless vehicle equipped with 360-degree view mapping cameras so that each vehicle can generate its own 3D map of the area, which will automatically be updated every time the vehicle drives through the area. In this way, each driverless vehicle can generate its own real-time 3D map of the area and will not need to rely on outdated pre-generated maps. Driverless vehicles will also be equipped with advanced sensor technology that is not easily fooled by poor weather. Combined with an artificial intelligence-driven onboard computer to handle the information, driverless vehicles can become much more effective and have a clear view of their own surroundings. Finally, driverless vehicles would be equipped with mobile network technology so they would be able to communicate with one another. Being able to communicate with one another in this way, driverless vehicles will be able to relay information to one another, which will allow each vehicle to create a clear picture of their surroundings. Driverless vehicles will have to rely less on sensor technology to detect incoming obstacles by gathering information from other driverless vehicles in the area that may have already detected the obstacle. In conducting my research, I found many existing technologies that could be applied to my proposed solution, including the current radar, LiDAR, camera technology equipped to Google's mapping cars, and the sensor technology and onboard computer equipped to the current driverless trucks being tested. Combining these technologies and equipping them to all future driverless vehicles, I believe could solve the issue of mapping and sensor technology in driverless vehicles. Security and maintenance are both potential obstacles that could be faced by my proposed system, though there is hope on both fronts. As I mentioned, cybersecurity in the driverless vehicle market is projected to double from $2 billion to $4 billion in the next 5 years based on the projected demand for security in autonomous vehicles. Maintenance could also pose an issue. With an abundance of sophisticated technology, driverless vehicles will no doubt require extensive and expensive maintenance. However, as I mentioned, there are some bright spots regarding the potential issue of maintenance. In the era of autonomous vehicles, your car will likely be able to schedule and drive itself to a repair shop, leaving you free to do other things. And on the issue of cost, Tesla recently proposed the idea of combining the cost of maintenance with the cost of the vehicle. In other words, you'll pay for the upkeep up front when you pay for the vehicle, meaning maintenance will be less costly in the long run. Using the discussed systems and the way I'm proposing, I believe that we could solve several issues with driverless vehicles using already existing technology.